space, MailGuard and Deakin University have teamed up and set to release the world's first artificial neural network that classifies spam and dangerous emails. The program uses machine learning algorithms, which lets it learn and adapt, making it essentially an artificial brain. Well, for more, Craig McDonald, the CEO of MailGuard, joins us now from our Melbourne studio. I'm assuming this is a little bit more advanced than blue tack on the camera of our computers. Craig, just talk us through, what is it?
Yeah, thanks, James. Look, artificial neural networks is essentially, as you described, a brain. We've got cyber criminals out there that have access to the same technology to try and stop threats. So we have to take a different course of action to prevent and to predict these threats from occurring. So rather than just using a traditional layer, we want something to start learning about good behaviour, but equally around the bad behaviour, and hopefully preempt those threats from arriving into our inboxes, both in business and also in the household.
So is that the key advantage, the predictive nature of it? Because as we know, that the threats are constantly evolving.
Yeah, absolutely. I think since the start of 2015, there's been billions of dollars spent by businesses, both in business and in consumer world, to try and prevent cyber criminal activity. And the cause of that is the fact that a lot of these actual criminals, sorry, actually I don't have a water, my apologies.
No, that's all right.
Don't actually understand why these criminals are behaving this way. The criminals actually purport to be the brands and people that they know, and so it's quite easy for that deception to occur. So the actual predictiveness of the nature of the technology we're designing is to try and help out those individuals, whether at work or at home, take that guesswork out and allow them to get on with their daily chatting on email.
As we mentioned in the introduction, this has sort of been in conjunction with Deakin University. How long have you been working on this? How long has this been in the pipeline?
Yeah, so the last 24 months we've been working on it at MailGuard, and in the last 6 months we were looking at universities to help start to formulate the AM, which is the artificial neural network. So Deakin, we've been working with the last 6 months to start tidying up. And around that is around the research of identifying the email, as I mentioned before, about being good mail and bad mail. So we've essentially put in hundreds of millions of emails through the machine to see, well, what is it actually learning, and is it actually preempting threats from occurring? MailGuard actually look and stop threats today through a hybrid approach of the AN, and we're doing very well with that. And so what we're looking for is a full version of the artificial intelligence.
And will it be able to do it without reading the actual email? Because I imagine that would be of concern to people, that privacy issue. Yeah, look,
it has to look at the behaviour of the email. So it's not really, although it's reading per se the email itself, it's the metadata that's sitting within the email, not necessarily the conversation, although that does play a small part in that. Particularly around threat within business is what's called spear phishing, which is essentially where the criminal is purporting to be, for instance, a CEO within a business, sending an email through to the finance person, and it's literally 5 or 6 words in an email. So there's no actual payload, so there's no malicious content. As such, it's requesting them to make a deposit into a bank account. So, you know, that really does need that bit of email to be read and understood, but it's the metadata. Where did the email originate from? What's the actual word saying? Not necessarily in the string of a sentence. It's looking at about 10,000 different characteristics of that particular email and preempting, is this a good email or a bad email?
All right, unfortunately, got to leave it there, Craig. Appreciate you joining us today. Thank you.